Hello everyone and welcome back to our Advanced Technologies class on demand. My name is Anthony Sequeira and I'm thrilled you're joining us for this next lesson in which we are going to look at none other than spanning tree protocol. And we're going to start at the most logical starting place, a review of 802.1d as in David, that's classic or otherwise known as legacy spanning tree protocol. I'm often accused of being a bit loopy, and what we want to do with spanning tree, or what spanning tree's whole job in life is to prevent layer 2 bridging loops. Layer 2 loops, if there's a loop in the layer 2 topology, it's immediately devastating. Broadcast storms are something that would nearly immediate result of the layer 2 loop. Let's go right now to a catalyst switch and see what's going on by default. And I guess I've given it away on screen here. By default, we're going to have Cisco's per VLAN spanning tree plus be in action on our catalyst switches. And that means we are going to, by default, get one spanning tree protocol instance calculated per VLAN. Even if you don't want this per VLAN distinction, it's what you will have by default in the Cisco catalyst switching environment. By the way, this PVST plus, it's a Cisco proprietary solution. So before we cover anything more, let's jump over to one of our switches and see what's going on. So here we are at our old friend switch 4. Let's go ahead and do a show VLAN brief. Remind ourselves of the VLANs that we have going on in this topology. And now we'll go ahead and do a show spanning tree for the VLAN 67. Now, what I want us to focus in on, notice we get a lot of great data with this command. What I want us to focus in on right now is the spanning tree is enabled and the protocol lists as IEEE. That's not really telling us a whole lot, is it? IEEE. What we have to know about this is the fact that this means we are running classic spanning tree protocol. Now, what specific implementation by Cisco? Well, let's do this. Let's go into global configuration mode, and we're going to do spanning tree mode ? Okay. Here we can see there's per VLAN spanning tree mode, that's PVST plus, and that's the default. That gives us this IEEE designation up here. And we have the MST, we'll talk about that in a future lesson, that's multiple spanning tree mode, otherwise known as 802.1s. And then there's rapid per VLAN spanning tree as an option. Cisco added this rapid per VLAN spanning tree for folks that wanted to do rapid spanning tree, called 802.1w, but they didn't want to do MST. They weren't ready to make the leap to MST, but they wanted the quicker convergence of the rapid spanning tree protocol. So those are the options that we want to be familiar with on our 3560 catalyst switches. Remember what happens in spanning tree protocol. We have phase 1, which we find a root device, a root of the spanning tree. And we remember that this election process is based on the bridge ID. The lowest bridge ID is going to win out. Now, bridge ID is made up of bridge priority and MAC address, plus the extended system ID, which is just the VLAN identifier. But obviously, the component that you're interested in is bridge priority. That's your tool as the administrator to control the spanning tree topology. And we'll take a look at that at the command line in a moment. Once we have that root of the spanning tree, we go through a root port election process that is just trying to figure out who's got the lowest cost to the root. And that cost is, of course, based on bandwidth. When we block a port, we want to make sure we are blocking the lowest bandwidth path for the prevention of loops in the topology. Obviously, one of the great things about using a 4-switch topology like we have in the lab and we have in our practices is that we've got plenty of opportunities for loops. Notice there are 3 links that connect each of the devices to each other, so we have this wonderful topology to practice spanning tree protocol manipulations. In fact, let's go ahead and review some more information and then jump right back into the command line so we can bring this discussion to life. The election of the root device is quite simple, but something that students really tend to need to review is the process for the root port election. Remember, it's going to be based on the lowest cumulative cost, and that's an inverse value based on bandwidth. So a lower cost means higher bandwidth. If there is a tie, and there often is a tie in this value, it will look at the upstream bridge ID to try and figure out which should be utilized. And in the case where you have a switch plugged into itself, where that bridge ID can't be used as a tiebreaker, the lowest port ID, the lowest port identifier, literally like 0/1 would win out over 0/10. So notice the real point here is that obviously because the loop prevention, because the blocking of a port is so incredibly critical, we absolutely have to do it. We can't have a tie. We have to pick a port to block. The port that we block in classic spanning tree protocol is called the non-designated port. So let's take a look at this output and see what we can see, so to speak. Well, first of all, it jumps out at us that switch 4 for the VLAN 67, it is not the root device. I can tell that right away. And that's because we've got some ports here that are blocking. Look at that. If we are the root device, we're going to see by definition that every single port is forwarding. So I can tell right away that we can't be the root. We've got some ports here in the blocking state. Also, if we look up here, we see that our priority value, 32835, that's the default plus the VLAN ID of 67. We see that our MAC address is listed here, and then the MAC address of the actual root is listed here. So we're definitely not the root device, and we can see which of our ports are forwarding and which of our ports are blocking from this output. Now, what if we want to become the root device? Well, we're going to manipulate the priority value. One of 2 ways to do it. You can manually set the priority value, or you can go ahead and you can use a command that's always described as a macro type command. What the command does is it surveys the priority values of your neighboring devices, and then it sets your priority lower. Let's try that macro command. By the way, often confusion about that command is the fact that once it does its magic, it's over, it's done with, it's done for. Lots of students think that that command is some type of additional protection mechanism and it will stick around and make sure we're the root. And unfortunately, that is all misinformation. It does not work that way at all. This command just does its magic initially, and then the command has no effect on your devices. So we're doing the setting of the root here. So let's go spanning -tree, and let's take a look at our options. We've got VLAN. That's what we want to do. We want to manipulate the parameters for a particular VLAN. And of course, you could use a range there if you wanted to do this for all of your VLANs. And notice we say spanning tree VLAN 67, and then there's the option to, of course, hard code the priority value. But what we're interested in is this macro, this root command. And then we have the option to say this is the primary root or this is the secondary root. What will happen there is with secondary, it'll adjust it so that it's not the lowest possible value to win, but the second best value. So it'd be the machine to use in the event of an emergency, like a failure. All right, so we're interested in this being the primary root device. So I issue that command, and now the magic happens behind the scenes. I'll go ahead and end our configuration, and I'll do the show spanning tree output again. And look at this. This is pretty cool. We are definitely now the root, and I love this. This bridge is the root, just in case we missed it. And notice that this is cool. We ran the command so fast we're actually transitioning some of the ports right now. We're in that listening state, that transitionary state. Let me rerun the command. Yeah, we can see now everything is converged, and by definition, every single one of our ports now is indeed forwarding. Well, we know that we're the root for switch 4, or switch 4 is the root, and all of its ports are forwarding. Let's go and look at a neighboring device now. Let's go over to switch 2, for example, and let's do show spanning tree for VLAN 67. And sure enough, we can see that it is obviously blocking on some of the ports in the topology. Notice also here that the port channel from our ether channel earlier is picked up. It just so happens to be in the blocking state. Notice it has a real low cost because obviously the port channel is a very, very high bandwidth connection. So what's so cool about this is you can see how the logical ether channel is picked up here and treated as one link in spanning tree terminology. And that's how the ether channel works. The links in the bundle won't be blocked because they're all treated as one link. And let me say that correctly. The individual links inside the bundle, not one of those will be blocked. Isn't that great? So, I mean, you might have the whole link itself blocked, like in this case, but the beauty of the ether channel is it's treated like one logical bundle from a spanning tree protocol perspective. Now, we can manipulate everything in spanning tree protocol. That's the great news. You have tremendous flexibility. You can go in and you can set the root like we did. You can go in and you can manipulate which of these ports is going to be blocked using the cost value on the ports. So just remember, lots of flexibility when it comes to the manipulation of spanning tree protocol. By the way, we see the priority here on this device is 24643. So that's got to be the secondary route. Let's jump over to finish this illustration. Let's jump back over to switch 4 and see what was set as the priority over there. 24643 was used as the priority value. Look at that, 24643. I'm still on switch 2. Wait a minute here. What's going on? The priority value... Oh, that's the priority of the root. Okay, I'm like, wait a minute here. How can two different switches have the same priority value as a result of that command running? That obviously can't happen. So we see what's going on here. This is a perfect place to look at it. On switch 2, it's 32,835, the default, and the root's priority is 24,643. So because everyone was set to the default priority, notice our little macro command didn't have to do much work at all. It just had to lower the priority ever so slightly in order to have our switch 4 take over as the root device. You know Cisco, they never sit around and wait for a standards body to improve a protocol. They have made plenty of improvements to performance and plenty of security enhancements to spanning tree protocol. Here they are so you can review them, and I'll show you where they're located on the doc CD in just a moment. We've got PortFast. This is going to be used on interfaces that connect to workstations and servers. When we know there is no need to cautiously transition from one state to another because we're never going to plug in a bridge or a switch out that port, we can initiate PortFast, which is going to skip those listening and learning phases. The BPDU filtering to prevent BPDUs from going out or being processed in on a port. We got to be careful with BPDU filter because it could inadvertently be used to create a loop. Or I suppose you could maliciously use it to create a loop if you wanted to prank one of your Cisco engineer friends. The BPDU guard, I love this. If we configure port fast, we might want to drop in BPDU guard just in the event someone inadvertently plugs in a switch on that port. It'll shut down that port if a BPDU is received. There's root guard, this is great, to protect our root device from some other rogue root from taking over. There's uplink fast, which is something that we're going to configure on our access layer switches so that they transition their non-designated port more quickly when a root port fails. So that's neat. It helps the classic spanning tree to converge more quickly on a direct link failure. There's backbone fast, which we would enable on all of our switches to more quickly converge when there's an indirect link failure. And then finally, loop guard, which is used to prevent the inadvertent loop thanks to something like, a unidirectional link, where a link is fine sending in one direction, but is not okay sending in the other direction. So lots of great protection mechanisms. And you might want a little bit more details about one of these. I mean, maybe you're like, oh, Anthony, give me a break. Port fast, backbone fast, and uplink fast. I've studied those for years as part of the associate and professional curriculums, but I've never even heard of root guard. And if you're in that case and you want some more information other than the high level we've given you here, let me show you how you can go ahead and easily obtain additional information about each of these mechanisms. Well, here we are at Cisco's website, and we're going to get more information about, let's pick root guard, the one we just gave as an example. I'm going to go to support, and I'm going to go to configure. Now, I bet you can find it in the configuration guides. But let's say we want to get more information about the command from the command reference, another great place to visit on the doc CD. As a matter of fact, let's say we went to the configuration guide and we weren't happy with the coverage that we got in the configuration guide. Here's how we can get more information from the command reference for the command. I'm going to start the same way. I'm going to go switches, LAN switches, and I'm going to go to the 3560. But instead of choosing the configuration guides here, I'm going to go over to the left and I'm going to select reference guides. Clear as mud, right? And then I'm going to click command references. And then pick the latest version of software. That's going to pop up my new window, which is the command references. And now I've just got to figure out what the command is. Now, obviously, when I looked up root guard in the configuration guide, that would give me the command. And so I write down the command, and now I'm going to come in and find it in the configuration guide. So let's see. Spanning tree, I think it starts with. So let's see. Shut down through VTP. Yep, this would be the right listing. Spanning tree. Let's see. Oh, my browser just hung up there for a moment. Spanning tree guard. Here we go. And then root. So spanning tree guard root. Whew, glad I came up with that from memory. And here we go. Here's information about the command. Spanning tree guard root, even an example, and we may get better information here on the command than we did in the configuration guide. So it's very important to be ready at a moment's notice to jump into the command reference to look up more information on a command as opposed to the configuration guide. Well, I hope you've enjoyed this lesson in our Advanced Technologies class. We have another lesson coming up, and of course, that lesson is going to be on the next generation of spanning tree protocol. We're going to look at Elmer Fudd's favorite protocol, it's WAPID Spanning Tree Protocol in the next lesson. Sorry about that bad joke, but every training class I teach on Spanning Tree, I've got to poison you with that terrible joke about Elmer Fudd and WAPID Spanning Tree.